our definition for congruent figures. So please write the following in the top box. Congruent figures are when two figures have the same angle measures and same side lengths. And the word figure is just the same thing as shape. So congruent shapes is when two shapes have the same angle measures and the same side lengths. We just use the word figure instead of shapes. Okay? So when you have congruent figures, you have what is called corresponding parts. Now think back to chapter 3. Remember we had corresponding angles? What were corresponding angles? Give me a set of corresponding angles. Anyone? 1 and 5. Give me another one. 2 and 6. 4 and 8. 3 and 7. So corresponding kind of means what? What does corresponding mean?
The same.
What's the same?
The angles.
Even more. Well, these are the same angle.
Degree.
These are the same degree and they're not corresponding.
The same side.
What makes them corresponding? They're on the same side of the transversal and... Right, so top left, right? Top right. Bottom right, bottom left. So out of these sets of 4, right? The top left angle is corresponding with the top left angle. Out of this set of 4, this would be the top left. And out of the bottom set. Yes. So corresponding, same position. So the same thing applies in congruent figures. So corresponding parts are matching parts of congruent figures. And there's a second sentence in this box. Let's put a period at the end of that. Figures. There are corresponding sides and angles.
Angle.
Can I just write core for short?
They're in your notes. So in a triangle, how many corresponding parts would you have if you have corresponding sides and angles? 6, right? So you would have 3 sets of angles, 3 sets of sides. In a quadrilateral, how many corresponding parts would there be?
8.
8, because 4 sides, 4 angles. How many in a pentagon?
12. No.
10.
There's 5?
5 and 5.
Dang it.
How about in a dodecagon?
Dodeca, that's 20. 20, idiot.
24. Dodeca is 12. How about a googlagon?
That's not a million.
Whatever double of a googlagon is. I don't know, a double of a googlagon. Okay? All right, so to our first example here. We've got 2 triangles here that are congruent. So I'm going to write a congruence statement.
I want to do that.
So a congruent statement is what? Something congruent to something. In this case, we're talking about a triangle congruent to another triangle. So how would we name this circled triangle right there?
ED.
You would call it triangle
CAG.
CAG, what do you want, dude? That's CAG.
That's a B.
Oh, I was reading the G on the other
See,
triangle.
the other one's LESTR.
All right.
LSTRB.
So just like in geometry, you always have symbols to represent words. The symbol for triangle is a triangle. Okay. So we have triangle CAB. Does order matter? No, I could do triangle ABC or I could do triangle BAC. Doesn't matter. What does matter is your second naming of your triangle. So triangle CAB is congruent to triangle. Now I have to match my corresponding parts. Now this is really important, so make sure you pay close attention to it. It's so easy that I don't want you to mess it up. I have C listed first. Notice down here in the diagram, C has the double arcs. What angle over here has double arcs? H. So now I'm going to call it triangle H. What will come next? F, followed by G. Does everybody see where that came from? A is the right angle on the left. F is the right angle on the right. B has a single arc. G has the single arc. Okay? So, can you write a congruent statement? Yes or no? Okay, so now, from this congruent statement, then you can easily match up your corresponding parts. So the second part of this problem wants us to identify all pairs of congruent corresponding parts. So let's do the angles first. How many angles should there be? 3, because there's 3 angles in a triangle. So, once I have my congruent statement, and as long as my congruent statement is correct, I don't even need to worry about that diagram over there, because now my corresponding parts should just match up with the left and the right. So angle C would be congruent to angle H. So I'm just going to write that out. Angle C congruent to angle H. Angle A would be congruent to angle F. Angle B would be congruent to angle G. See that? I could use the diagram to get that, but it's much easier just to look at it from here. Well, yeah, you could do that too. Now let's do the sides. So now we need to have 3 sets of sides shown congruent. Now watch how this works. How do we name a line segment? How many points do I need for a line segment? 2. What's the symbol that goes above the letters? Just a line, no arrows, right, to name a line segment. Here's 2 letters. Would that represent a side, CA? Sure. So side CA would be congruent with side HF. First 2 letters would match up with the first 2 letters. Do we see that? CAHF. What would match up with AB? FG. So AB, line segment AB, is congruent to line segment FG. What's the last side that I'm missing? We did these 2 together. We did these 2 together, so we need the first and the last. So CB would be congruent to HG. Corresponding parts. Do you see that? All right, so before we move on, I want to make sure we have this. Can I erase that? I'm just put a blank slide up. All right, so if we had triangle TRS, nope, just pay attention. We're going to cycle through the class. Are you ready?
Is this for example 2?
Nope, this you just make sure we've got this. All right, Hannah, you're first. Angle R, quiet guys, would be congruent to angle what? Does everybody see how angle R would match up with I? All right. Christian, you ready? Angle T would match up with angle
I'm gonna say
M is correct. Zach, you ready? SR, line segment SR would be congruent to what? OI. Good. All right, who's next? Cam? Ready? Angle I would be congruent to what? Good. Ooh, don't do that. Joe. Erase, erase, erase. Can I give you a hard one? Angle. You ready? RTS would be congruent to what angle? Perfect. Max. ST would be congruent to OM. Perfect. Devin. What would be SRT? Angle SRT. Congruent to.
OIM.
Yes.
ER. D.
Adam.
Yes.
RS is congruent to.
IO.
Good. Colby. OM is congruent to. Good. Kelsey. Angle M is congruent to. Good. Bailey. IM is congruent to. Good. Fiona. Angle I is congruent to. Good. Trevor. Angle MOI is congruent to. TSR. Good. Gavin. Angle O is congruent to. S. Sky. MI is congruent to. Good. Dylan. Angle S is congruent to. Noah. Angle M is congruent to. Good. You ready? Oh my God, Justin, I just had a brain fart with your name. I'm thinking of too many combos. Justin, let's do angle OIM.
SRT.
Perfect. And Brooke, last but not least, MO would be congruent to. Good. All right, so we've got that down. So you'll be able to do that on the quiz on Tuesday? Good. All right, back to your notes. So now we're going to throw some algebra into our lives. So now do I have triangles anymore? How many sides do my shapes have?
1, 2, 3.
So we would call those
Squares.
quadrilaterals. Thank you. So there is no symbol for quadrilateral. There is no symbol for pentagon. There is no symbol for hexagon. So anything that goes beyond 3 sides, you just put the letters of the vertices. You don't put a symbol in front of it. Okay. So here we have QRST is congruent to WXYZ. We're solving for X. We're solving for Y. So really quickly, so don't get confused, this is a capital X. This is a lowercase x. So we're not solving for this x down here. That's just the name of that vertex, of that angle. So where do I have lowercase x's? Well, I have a lowercase x here, and I have a lowercase x right here. The one I highlighted in, Yeah, just ignore that x. It really has nothing to do with anything except the side. This has a y. Guys, quiet please. This has a y and an x, so I'm probably going to ignore it for now and focus just on the blue, which just has 5x plus 5. So the next question you need to ask yourself is this expression inside an angle or representing a side length?
Representing the side length. Or no. Within an angle.
Why? Because it has a little degree sign here. So what specific angle is it in? W. So now jump up here. W is the first letter. What's the first letter on the other side?
Q.
So W and Q would be congruent. So give me an equation to solve for x.
5x plus 5 equals
Good.
So we have to do that for every letter.
Well, no, you're just solving for x and y. So 5x equals 60. So x is equal to 12.
So do I have to do that for R and X and then?
No, because I don't have other variables there.
I don't have to do that.
No. So now let's get our y. So going over here to the pink, we have a y minus x. Guys, please stop. We just said x was what value? 12. So let's cross that out and turn that into y minus 12. Now is that on a side length or in an angle? A side length. Specifically what side length? WX. WX matches up with QR. What is the length of QR? 6. So what would be an equation?
Y minus 12 equals 6.
Good. Which will get us y equals 18. Good. Okay, so utilize your congruent statement because that's going to be very, very, very helpful for figuring out what is congruent to what. So what then do you equal to what? Okay. All right, once you have that, flip on to the back. Here's our first theorem for the chapter, which is Theorem 4.1, the third angles theorem. So please write the following.
That's 4.3.
That's just 4.3.
On yours?
Yep.
No. No, it doesn't really matter. As long as we got the name down. So please write if two angles of
Watch this.
one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Getting this, Gavin? Okay, so this is kind of one of those, it just kind of makes sense. Let's pretend that B, don't write this, just watch. Let's say that B is 100 degrees. What would then E have to be if they're congruent? 100 degrees. And let's say, for fun, that A is 50 degrees, which then makes C, or D,
30.
Well, C would be 30, yes. What would be D?
50.
50.
Duh.
And then F would have to then be 30. So is F and C congruent?
What's up?
Are F and C congruent?
Sure.
Yeah. Correct. So if you already have two congruent angles, then it must be true that the third will be congruent, is what this theorem says. If you have two sets of congruent corresponding angles already shown congruent, then it must be true that the third will also then be congruent. Just kind of comes along, right? And we use this kind of for a shortcut when we're doing our proofs. Okay? All right, so let's do this last example before we get to the proof. You ready? We need to solve for the measure of angle V. Who thinks they have it? Do you have one set of congruent angles up there?
No.
Yeah.
Yes.
Oh, I see them. I see
Right
them.
here and right here. Where's your other set of congruent angles?
44.
Why are those congruent?
Vertical. Horizontal. Whatever.
Vertical, you were right.
Okay.
Well, up top.
So do you have two sets of congruent angles already?
Yes.
So doesn't that mean that the third sets have to be congruent?
Yes.
Can you find the measure of angle S?
Yeah.
How would you do that?
66.
70.
No, wow.
Equals to 180.
Stop touching me.
So that's 110. When you add those together,
It's identical to the bottom.
subtracting it gets you 70. So if S is 70, the third angle theorem tells us then that V is also 70. Good.
Wow.
They're fat.
This is
Could you get there the long way? Sure. You could have just said this was 60, this was 44, and then do the same math, right? That would get you to the 70. But either works. All right, are you ready to get a proof back into our lives? Thank you to those who started making a T-chart already.
I did it.
Statements on the left. Reasons on the right. We are going to be very lazy with our given. Just write a big given across the top. So line 1, just put given. So that's a whole lot of stuff to write. We won't do that. Now look what we're trying to prove. We're trying to prove that one triangle is congruent to another triangle. And what did we just say back at our first example? If I had congruent triangles, then we listed how many sets of corresponding parts? 3. 6, right? We had 3 sides, 3 angles back in our first example where we wrote a congruent statement and then we showed our 6 corresponding parts that were congruent. Is everybody with me? So if we do that in reverse, how would I prove that I have congruent triangles? I would need to have 6 corresponding parts being shown congruent. Did everybody soak that into their brains right there? That was a lot of words. Did you get that? How many corresponding parts do you have in the given? 4. Right? 1, 2, 3, 4. How many are sides? 2 sets are sides. 2 sets are angles. So what am I missing out of the 6 corresponding parts? 1 angle, 1 side, right? So if I can get my angle congruent to an angle, and I can get my side congruent to a side, then I would have all 6 parts to say that I have congruent triangles. There we follow that. I hope so. So let's figure out where the missing pieces are. Notice the diagram's already marked up for you. Where's the angle that we're missing? D and B. All right, so let's get in there. So angle D needs to be congruent to angle B. Why would they be congruent? What theorem tells me that if I have 2 angles already congruent to 2 angles on another triangle, then the third angles must also be congruent? Third angle theorem. So we're just going to write it out. Third angle theorem. Now do you have all 3 corresponding congruent angles? Yes, because you had 2 in the given. Now we have the third. So the angles are done. What side am I missing? What side is not yet being shown congruent? AC. Who said that? Colby? Nice. In the middle here, right? Now look at your prove congruent statement. AC should match up with what over here? CA. So let's write that. So AC congruent to CA. All right, Colby, can you get this? Why is that congruent?
Are you Colby? No, so shut your mouth.
Colby's giving me I don't know look. Anybody? Joe? Oh, well, they are. So keep going. What property lets me do that? Reflexive property. Nice, Max. What does the reflexive property tell us?
Oh, it's the same thing.
Yes, it is the same thing, right?
Yeah, roll 2 out of 10.
So the reflexive property. Now do you have all 6 corresponding congruent parts? Yes, you do. So let's rewrite our prove line. Triangle ACD is congruent to triangle CAB. Can someone give me an if-then statement for that? What did we just do above all of this? What did we just do over here? What are these? What's the tongue twister I've been saying all day? Congruent, corresponding parts, right? Well, we just say parts to generalize it. So if corresponding parts congruent, then what's true?
I hear the footprints on the roof.
Then what's true?
Miss Crowley, you gotta make a chimney real quick.
Remember, your conclusion should match up with what's over here. So what should be my conclusion of that if-then statement? Or generalize it, then congruent triangles. Good. Then congruent triangles. Okay? Now, this is where we are going. The reason why I don't force you to do these proofs yourself is because the rest of this chapter is about shortcuts. Because wouldn't that be a really long proof if we had to prove every single set of corresponding parts congruent every single time to say that I have congruent triangles? So the rest of the chapter is about shortcuts and what we can do to condense our proofs.